Hello friends, welcome to engineering tutorial. So we will resume our discussion on the subject of satellite communication systems, and here in the next series of videos we will be discussing about one of the most important topics related to this subject, that is satellite communications, which is the topic of gravitation. So in the next series of videos we'll be discussing all the basic and important things which are related to gravitation in relation to satellite communication systems. Okay, so let us start. So first, what is gravitation? So gravitation is that force which is holding this whole universe together. Okay, the reason why the planets, they move around the sun, revolve around the sun in fixed orbits, why the moon moves around the earth in fixed orbits and fixed intervals of time, why the artificial satellites, they move around the planets or earth in fixed orbits in fixed intervals of time. So the reason for that is the force which is holding them together, and that is the gravitational force of attraction. Now if we take gravitation out of the equation, then the whole universe will fall apart. There will be chaos. So it is gravitation which is bringing order into this whole system, okay, into the whole solar system. So every object, every body in this universe, it attracts every other body with a force which is called as the gravitational force or force of gravitation. It is the force of attraction between any two bodies in the universe, any two objects. Okay, so the force of gravitation between the sun and the earth, the gravitational pull of the sun causes the earth to revolve around the sun for the entire year. Similarly, the gravitational pull of earth causes the moon to move around earth. Similarly, the gravitational pull of earth, it causes the artificially launched satellites to orbit around earth or the respective planets where it is launched for various purposes. Similarly, any object, two persons, there is a gravitational force of attraction between them. Inanimate objects, any non-living objects also, chair and table or any object, there is gravitational force of attraction between them. So there are some fundamental forces in nature which hold this whole universe together. Okay, so those fundamental forces are gravitational force, electromagnetic force, strong nuclear force and weak nuclear force. Out of this four fundamental forces, gravitational force is the weakest of the four fundamental forces, but it is the most important force because it has played an important role in holding this universe together, this solar system together. Okay, so in initiating the birth of various stars and controlling the structure and evolution of this entire universe, gravitational force has played an important role. Okay, so that's why gravitational force, despite being the weakest, it has a very important role. Okay, and it also plays a very important role in the concept of launching of satellites, the movement of satellites around planets and many other things. So we'll go to that, but slowly we will start from the easiest topics, then we'll go to the intermediate and then the advanced. So next is gravity. So gravity is a special case of gravitation. So we know that if there are two objects, then there is a gravitational force of attraction between them. So either object, it attracts the other because of gravitational force. So if one of the objects in this two object system or two body system is earth, it can be between the sun and the earth and the moon, the earth and the satellite. in that case, or the earth or any other object, earth and a person, so in that case, if one of the attracting objects or bodies is earth in the two body system, then the nature of the gravitational force is called gravity. Okay, so the definition of gravity is the force of attraction between the earth and any other object, any other body lying on or near its surface. Okay, so every object, it attracts the other through gravitational force of attraction. So if one of the object is earth, then the gravitational force of attraction is called as gravity. Okay, next is free fall. Now, the motion of an object or body under the influence of Earth's gravitational force of attraction or gravity alone is called as free fall. Okay, suppose we throw a ball high in the air, it falls down. Okay, the reason for it is gravity. Okay, Earth's gravitational pull. If we throw a box from the top of a tower, it will fall down. The reason for that is gravity. The gravitational pull of Earth, it brings the box down. A fruit, it falls from the tree. Okay, so the reason for that is gravity. Now, the interesting thing in all of these cases, the three cases, is that all the objects which fall under the influence of gravity, they have one thing in common, which is acceleration due to gravity. Okay, acceleration due to gravity. So when an object or a body, it falls freely, it is in free fall under the influence of Earth's gravitational pull or under the influence of gravity, its velocity, it increases continuously in equal intervals of time, by equal amounts in equal intervals of time. So as a result, the resultant acceleration which is developed in its motion, acceleration is change in velocity by change in time taken. So as the velocity is increasing by equal amounts in equal intervals of time, the resultant acceleration which is developed, it is constant. So that acceleration, because of Earth's gravitational pull or gravity, that is called as acceleration due to gravity. It is denoted by small g. Okay, so the definition of acceleration due to gravity is the acceleration produced in a freely falling object under the influence of Earth's gravitational pull because of Earth's gravitational force under the influence of gravity, that is called as acceleration due to gravity. And the value of acceleration due to gravity is 9.8 meter per second square. For now, just remember this. There is a lot of other discussion related to it. Acceleration due to gravity, it has various other characteristics. We'll go one by one in detail about them. So when an object falls under the influence of gravity, its velocity increases by 9.8 meter per second. That's why 9.8 meter per second square. Okay, it changes by 9.8 meter per second. So every 1 second, the velocity changes by 9.8 meter per second. Okay, so acceleration due to gravity, it has a value of 9.8 meter per second squared. Okay, so every object which is freely falling, whether it is a ball, a box or an apple, it will have the same acceleration due to gravity, regardless of its size, shape, mass, whatever. Okay, now the important characteristics of acceleration due to gravity. So acceleration due to gravity, as velocity is a vector, acceleration is a vector. So acceleration due to gravity is also a vector and it has a direction which is pointed towards the center of the earth. Okay, it is a vector having direction towards the center of the earth. Now, as I said, it is not dependent upon the mass, shape or size of the object. Regardless of the mass, shape, size of the object, nature of the object, if an object is falling freely under the influence of Earth's gravitational pull, it will have the same value 9.8 meter per second square, which means the velocity will change, increase or decrease by 9.8 meter per second for every second that passes. Now, why velocity? In case the object is it is thrown downwards freely, okay, without any initial thing, in that case the velocity will increase, but if it is going upward, it is thrown upwards, then velocity will decrease and ultimately it becomes zero. Okay, that part we have covered in mechanics. Okay, in one-dimensional motion, uniformly accelerated motion, all that you can check the mechanics playlist. Okay, so that is the second characteristics, that is, it does not depend upon the mass, size or shape of the object. Then acceleration due to gravity is constant at a given place on earth. Okay, it is constant, the value is constant, but it varies from place to place. Okay, acceleration due to gravity, the value of acceleration due to gravity, that is 9.8 meter per second square, it is near the earth's surface, but as we move from the equator to the poles, the value, it will change. Now its value, it depends on the altitude, depth, shape and rotation. So here latitude it comes into play, so it depends upon the altitude, depth, shape and rotation of the earth, so it changes with that. Okay, so at any given place the value will remain constant, but as we move in different places, we move from one place to another, the change in altitude, change in depth, shape and rotation of the earth, the value of acceleration due to gravity will change. Okay, next is weight of an object. Now the weight of an object or a body, it is a measure of earth's gravitational pull. Okay, so basically weight of an object is the mass of the body or the mass of the object multiplied with acceleration due to gravity. So if mass of an object is m and acceleration due to gravity is small g, weight is mg. In vector form, it is w vector is mg vector. Okay, again the weight vector is directed downwards. Okay, so if we stand on a weighing machine, the reaction force of the weighing machine, it gives us the weight. Weight is the downward force and the reaction force, which is upwards, that gives us the weight. Okay, so weight of an object is defined as the gravitational force with which an object or the body is attracted towards the center of the earth. Why? Because acceleration due to gravity is also directed towards the center of the earth. So the resultant weight vector will also be directed downwards towards the center of the earth. It is a measure of earth's gravitational force with which it is attracted downwards towards the center of the earth. Okay, again characteristics of weight, same. Weight is a vector quantity. Why? Because when we multiply a scalar, that is mass, with a vector, that is acceleration due to gravity, we will get a vector. Again, as acceleration due to gravity is constant at a certain place, weight will also remain constant at that place, and as acceleration due to gravity, it changes as we move from place to place because of change in altitude, depth, shape and rotation of the earth. Weight of a person or an object also varies from one location to other on the earth. So it has units of Newton or kg weight. Okay, so these are some of the concepts, basic introductory concepts related to gravitational force and gravity. Okay, so here the weighing machine thing, when we place an object or a mass or a person, when we weigh them, it is basically the reaction force which we are measuring. The weight is acting downwards, the reaction force, that is measured by the weighing scale, which is indicated as the weight of the person. Okay, the weight of the person, mass of the person or mass of the object multiplied with acceleration due to gravity at that location, that place. Okay, so near the surface of the earth, acceleration due to gravity is 9.8 meter per second square, but it varies from one place to the other. So these are some of the basic introductory concepts related to gravitation and gravity. Okay,